So today we're going to talk about spheres. What do you think what part of spheres are you going to think, what are we going to talk about spheres, you think? What about spheres? Volume, sure. Volumes and? Surface area, right. Okay, so they just call it area for sphere, but we know what it means by area of a sphere. We mean it's the surface area of the sphere. One thing I want you to understand about spheres, there's a key number. The number is? We'll see. Okay, so let's see if you see you can figure this out. So let's think about sphere here. I'm going to draw a sphere. So to draw a sphere, you draw a circle. It's really easy to draw a sphere. Draw a circle. Let me make it a little bit better. And then you draw, like in the middle, you draw a little oval shape like this, and then on the back, put dotted line like this, and then put a center, and then put R. Isn't that nice? There's a sphere, okay? Sure. Yeah, okay. Try it. Okay, then, so we're going to find the surface area of the sphere. Okay? To find the surface area of a sphere, it's kind of interesting to look at the circle that's right in the middle of this sphere. Do you see that circle right in the middle of the sphere?
I do.
What is the area of that sphere? Circle?
Pi r squared.
Pi r squared, correct? Now it turns out the surface area is how many times it actually, if you were to compare the area of the surface area of the sphere with the area of the circle that's inside the sphere like this, it fits exactly how many times? Anybody want to guess? Okay. First of all, do you think it's going to be more than twice? Yeah. Okay. Do you think it's going to be more than 3 times?
Yes. It's gonna be.
It's actually, let me tell you, it's 4 times.
Look, it's an even number.
And so the key number for sphere is the number 4. So it turns out, you know that circle that fits in the middle of the sphere? If you were to multiply that area of the circle 4 times, it's exactly, okay, it fits, yeah, every time. It fits exactly as a sphere, the surface area of the sphere. Isn't that interesting? Huh? You can't really do this with water though, right? Because how are you gonna, this is surface area, it's not like volume. But when we get a chance, I want to show you, there's a sort of a, it's not really a proof, but there's a nice way of thinking about how you derive 4 pi r squared. But I don't think we have time today, but we'll do the next time when we get a chance. If you look at the book, they actually do that for you. So if you want to take a look at it, but for now, we'll just take this. Okay, is that okay? So the surface area of a sphere is 4 times the area of that circle that you see. Is that okay?
Yes.
What's the key number for spheres? 4. Very good. Now, what I want to do now is I want to look at the volume. Let me do this in black. So volume of the sphere now is, what I want you to do is I want you to look at this cone that fits exactly inside a sphere. Okay? What is the height of this cone? R again, because it's inside the sphere, isn't that right? So from the center to this, isn't that the same thing as the radius? Because it's inside the sphere. I want you to all find the volume of this cone, because once you know the volume of this volume of the cone is going to fit exactly how many times you think? It turns out, what's the key word? Key number for the sphere? Yeah, it's going to be 4 times the volume of this cone. So it's kind of nice to remember this number 4. And you know what I thought it was interesting? Look at the section. It's 12 point. You think they did this on purpose? I don't think so, but I think it just happened to me. But I'm just saying. I'm just saying. Okay, so go ahead. First of all, find then the volume, guys. Because if you know the volume of this cone, you multiply that by 4, because that cone will fit exactly 4 times inside this sphere. Go ahead, everybody try. I'll wait. What is the volume of this cone then? So, who remembers? Okay, how do we find the volume of a cone. It's going to be, volume of a cone is what? 1/3 times area of the base times height. You guys remember? So let's fill it in. 1/3 times what? What's the area of the base? Now, what is the height of this? So have you noticed that we have r squared times r? What does that give you? 1/3 pi r cubed. Correct? So we found the volume of the cone that fits inside of the sphere with the base being the center of the circle in the center. So it's 1/3 pi r cubed. So I'm going to put it right here, 1/3 pi r cubed. So that's the volume of a sphere. So, well, if you could write this simply, 4/3 times what? Pi r cubed. But I kind of like this better because it shows you the key number, right? Which is 4, right? You just basically multiply 4 times the volume of that cone. Is that okay? So what I want to do now is I want to show you something. So I have this. Yeah, I want to do the water thing again, but you know what? I do have a sphere, which is nice. But look at my cone. This cone, it does have the same center. Okay, if I were to open this up, it does have the same base, right? Right? Right. It fits right. So it fits exactly like this. But unfortunately, the cone is too high, isn't it? Look, I want the height of this cone to be what? Yeah, the same as the radius, but it's actually the height is the diameter of this cone. I mean, of this sphere. I don't know if you can see that. So, could I still do the experiment then? Yeah, because all you have to do is, instead of filling it with water 4 times, because it has the height as a diameter, I just have to do it twice. Does that make sense? So I can still do the experiment, can I not? It's just because we're lucky that this has the base is same as the center of the sphere. The height is twice as the radius. So the volume will be twice as much, right? So what I'm going to do is I'm going to fill this cone with water and pour it into the sphere, and it should fill how much once I pour it once? Half, right? Does that make sense? Because if it has this height of the radius, it will be 4 times as much. Because it's twice as much, it will fill half of it. So let's do that. I'm not going to pour it in twice. I'm just going to pour it once. Okay, so let's see. It'll hold. Okay, so here's a place where I could put this. Okay, let me fill this with water. Let's see if this is going to fill it halfway. Okay, so here we go. I'm pouring water in here. Oops. It's kind of tricky to do this perfectly, but you get the idea once we. Okay, here we go. That was good. Okay, I almost get rid of the bubble inside. Okay, see I fill this with water. Now I'm going to pour it in. Okay.
You just put the sphere on top of it and turn it over.
Huh? Oh yeah, let me just open this up. It's easier, right? Because it's going to fill half of it. Okay, I'm going to pour it in here. Let's see if it fills halfway. You see how it fills exactly half? You see that? I could open this up. Look, it's perfect. It's perfectly half. I could even. You see how it's like right? It's very right. Does that make sense? Pretty cool, huh? So I mean, I could do it again, but I'm not gonna. I don't want to do it. Okay, but do you understand what I'm trying to say? Okay, good. So as you can see, the volume of a sphere is 4 times, right, as much as the volume of that cone that fits in the middle. Okay, is that okay? All right, let's do some examples then. Okay. So example 1. It says, yeah, pretty straightforward. It says find the area and the volume of a sphere with radius 2 centimeters. This is very straightforward. Okay, go ahead. Everybody try this. Okay. Oh wait. By the way, what do they mean by area? Surface area. For a sphere, when it makes sense, they're talking about surface area. So when they say find the area of a sphere, they really mean to find the surface area of the sphere. Okay. So those were the two theorems, actually. The surface area and then the volume of it. Okay, so, all right. So go ahead, everybody try. So if you want to see the theorems, it's exactly what we had, right, up here, guys. Right, it says the area of the sphere is 4 pi times the square of the radius, which is what we got here, right? And the volume is 4/3 pi r cubed. But I showed you how we got those, okay? All right, go ahead, everybody try this. Okay, I'll wait. All right, how about Brandon? Over here. What did you get for the, it says find the area, so give me the surface area for this. What'd you, how much? 15 pi. How many people? What? 16 pi? You are correct. You just do 4 pi times, right? The radius square. All right. Who's got then the volume for this? How about Hannah? Lee? Oh, yeah. 32 pi over 3 is correct. Very good. Now, did you all put down the correct units for the area? Did you put down centimeter squared and then? Did you? Okay, you were supposed to. Okay. All right. And for the volume, did you put down? Thank you. Did you put down centimeter cube for the volume and so forth? Yes. Okay. Good. All right. Let's try one more. Okay. Here we go. Okay. Try example 2 here. It says, guys, the area of a sphere is 256 pi. Find the volume. Okay. Go ahead. Everybody try. I'll wait. Okay. Yep. Try. To find the volume, all you have to do is what? Figure out the radius is correct. To find the radius, we use the surface area formula. So it should be 256 pi equals to 4 pi r squared, correct? Yeah. Divide both side by 4 and divide both side by pi. You get r squared is equal to 64. What's r? 8. And once you know r, once you know the radius, can't you figure out the volume by plugging it into the volume formula? Yes? And so you simply get 4/3 pi r cubed. This time it should be 8 times 3. 8. Oh, does this mean 8 times 3 or 8 times 8 times 8? 8 times 8. Okay, so it should be, when you do, you get 2,048 pi over 3. Good. All right. Let's do the one last one real quick. Here we go. So it says a plane passes 4 centimeters from a center of the sphere with radius 7 centimeters. Find the area of the circle of intersection. So first of all, do you understand what's going on in this problem? Yes. Now really, here's the picture. They don't give you this picture, but once you see it, you go, oh, okay, that's what they mean. So you have a sphere. Imagine a plane, right? Whole plane going through this, and then you, not an airplane. Okay, no, we're not talking about an airplane. We're talking about plane, like in plane. No, not an airplane. Okay. Okay, if you were to cut this sphere, right, with the plane, right? Don't you get a circle? They want you to find the area of the circle. All you have to do is find the radius of the circle. Well, how are you going to do that? Pythagorean theorem. How do they know this was 7 right here? That's the radius of the sphere, correct? So using the, and then this is 4 because they told us it was 4 from the center of the sphere, correct? So we can find the x. X comes out to rad 33. And of course, to find the find the area of the circle, yeah, pi r squared. So you get 33 pi centimeters squared. Does that make sense? So when they say a plane passes through, it does not mean airplane. Okay, okay, any question? Can you do something like this for your homework tonight? Yes. All right, good.